Welcome, geometry students, to the homework help video, page 376, 11 through 48. Let's go ahead and get started right away with numbers 11 through 14. In numbers 11 through 14, the directions say to simply simplify the ratio or reduce the ratio. So 6 will go into both of these numbers. So the simplification would be 2/3. Okay, number 12, 36 over 24, 12 goes into both of these numbers. 12 goes into 36 3 times, 12 goes into 24 2 times. So the simplification or the reducing would be 3/2. Okay, moving on to number 13. Alright, let's see, 2 goes into both of these. So 2 goes into 22 11 times, and 2 goes into 40 20 times. So the simplification would be 11/20. Okay, and remember, students, just because you reduce by a certain number does not mean that the problem cannot be reduced again. So always check to see if your fraction can be reduced further. Okay, alright, number 14, 7 goes into both of these numbers. 7 goes into 7 once, 7 goes into 35 5 times. So the answer reduced, 7/35 reduced is 1/5. Okay, 1/5. Now for numbers 15 through 18, they want us to rewrite the fraction so that you have the same units and then simplify. Okay, so here we go. Now students, obviously look, you would not want to try to reduce this when you have feet and inches. Okay, we want them to be in the same unit of measurement. Whenever you're talking about measurements, you want to have the same unit. So 1 foot is 12 inches, so I'm going to make this 12 inches over 12 inches. Now we have the same unit of measurement in the top and the bottom. Now we're going to reduce this. 12 goes into both these numbers one time. So you're welcome. You are more than welcome to put 1 over 1 for your answer. I have no problem with that. Or you can just put 1. Either way is fine, okay? Alright, number 16. Alright, now understand something in case you're a little weak with your metrics. 1 meter equals 100 centimeters. Okay, so we have two choices. For 200 centimeters, we could put 0.20 meters, and we could over 1 meter. I really don't want to have a decimal within a fraction. That's really going to be a pain. So instead of converting centimeters to meters, I'm going to convert meters to centimeters. 1 meter equals 100 centimeters. So now I have 20 over 100. Well, cross off your zeros. 2 goes into 2 once. 2 goes into 10 5 times. So you're left with 1/5. Okay, that'll be meters compared to meters. Okay, 1/5. All right, moving on to number 17. Please don't forget that 1 kilogram equals 100 grams, or excuse me, 1,000 grams. So 1 kilogram equals 1,000 grams. Now, again, if you want to convert the top to kilograms, that's fine, but it's going to be 0.450 equals, 450 grams equals 0.450 kilograms. I really don't want a decimal within a fraction, so instead of converting the top and the bottom to kilograms, I'm going to convert the top and the bottom to grams. So 1 kilogram equals 1,000 grams. So now I have 450 over 1,000. So cross off a 0, and now I'm left with 450 over 100. Well, 5 goes into both of those, and you end up with 9 over 20, 9/20. Okay? So again, what we're trying to do here for numbers 11, numbers 15 through 18 is make sure that you're comparing the same unit of measurement with the same unit of measurement. Okay? Alright, number 18, we have ounces and pounds. Now, there's 16 ounces in 1 pound, so let me write that down. 1 pound equals 16 ounces. Now, listen carefully, students. If you have 12 ounces, that's the same thing as 12 over 16 pounds. The only problem with that is I now have a fraction within a bigger fraction, and that's going to be a pain. So instead of converting the top to pounds, I'm going to convert the bottom to ounces. 1 pound is 16 ounces. I have 2 pounds, so that would be 32 ounces. Okay, and now let's simplify this. let's see, 4 would go into both of these. 4 goes into 12 3 times, and 4 goes into 32 8 times. So 12 over 32 reduced is 3/8. Okay, 3/8. All right, moving on to numbers 19 through 22. You can read the directions in your book on their own. In 1992, the Dallas Cowboys won 13 of their. I'm going to put it right down here. I'm going to put DC for Dallas Cowboys. They won 13 out of their 16 games, so their record was 13 and 3, 13 wins, 3 losses. Now the other team was the Buffalo Bills. And let's see, they won 11 out of their 16 games, so they were 11 and 5, okay? 11 and 5, 11 wins, 5 losses, okay? With that in mind, let's answer these questions. What is the ratio of wins to losses for the Cowboys? Well, 13 to 3 wins, 2 losses. So they had 13 wins and 3 losses, so 13 to 3. Alright, number 20. Find the ratio of wins to losses for the Bills. Okay, wins, 2 losses. Well, the wins were 11 and the losses were 5, so 11 to 5. 11 to 5. Alright, number 21. Find the ratio of, are you ready, wins for the Dallas Cowboys, 13, to the total games. Okay, well, their total games is 13 plus 3, 16. So the ratio would be 13 to 16. Okay, now number 22. Find the ratio of wins. Not sure why I just did that. Here we go. Find the ratio of wins to total games for the Bills. Well, their wins were 11, and their total games were 16. 11 plus 5 is a total of 16. So 11 to 16. Alright, and there we go. Alright, moving on to numbers 23 through 30. The directions say to solve the proportion, okay? Solve the proportion. I'm going to go pretty fast. This is pretty elementary math. So here we go. Cross multiply. 2 times 3 is 6. X times 5 is 5x. Set them equal. Divide by 5, and your answer is 6/5, or 1 1/5, or 1.2. Okay, moving on to number 24. Cross multiply. 6 times 11 is 66. Y times 12 is 12y. Set them equal. Divide by 12. 66 over 12 would not be a good answer. You want to reduce first. 3 goes to both of these. 22 over 4. 11 over 2. So 6 goes into both of these. So 11 over 2 would be one answer, or 5.5, or 5.5. Any of those would be fine, okay? But these answers here, these fractions here, are not sufficient because they're not reduced. Okay, number 25. Cross multiply. 15 times b is 15b. 3 times 25 is 75. Alright? So divide both sides by 15, and b equals 5. Okay? B equals 5. Alright, moving on to number 26. A times 8 would be 8a. 4 times 3 would be 12. Let's divide both sides by 8, and you end up with 12 over 8. Reduce that by 4, and you get 3 over 2. And that's definitely a great answer. I have no problem with 3 over 2. Another answer would be 1 1/2, and another answer would be 1.5. Moving on to number 27. Alright, 4 times 9 is 36. 12 times x is 12x. Set them equal. Now divide both sides by 12, and 3 equals x. Pretty simple. Number 28. 3 times 5 is 15. 10 times z is 10z. Divide both sides by 10. And of course 15 over 10 would not be acceptable on the test or quiz. You need to reduce it. And 5 goes into both of those numbers. 3 over 2 equals z. And that is the correct answer. So you are welcome to put 3 over 2, or 1 1/2, or 1.5. Okay, number 29, we're going to cross multiply. 3 times x is 3x. And then 4 times x plus 2, 4 times x is 4x. And 4 times is a positive 8. Bring the 4x over and make it a negative 4x. So it's gone now. 3x minus 4x is negative 1x. Bring down your 8. Now divide both sides by a negative 1. Divide by negative 1. Divide by negative 1. X equals negative 8. Okay, x equals negative 8. Number 29. Alright, number 30, here we go. 2 times y is 2y. 3 times y minus 3 is 3 times y, 3y. 3 times negative 3 is a negative 9. Now bring the 3y over and make it a negative 3y. So now we're left with 2 minus 3, negative 1y equals, and of course this is gone. We moved it over to the left side. Bring down your negative 9. Divide both sides by a negative 1. And y equals 9. For number 30, y equals 9. Alright, okay, let's continue on. Moving on to numbers 31 and 32, the directions say to the ratio of AB to BC is 4 to 7. Let me write that down. The ratio of AB to BC is 4 to 7. Okay, now we're going to use that ratio right there for numbers 31 and 32. So here we go. They want us to solve for x. Alright, so think this through very carefully, students, okay? Watch this, please. 4 over 7. Now 4 is what? AB. 7 is what? BC equals. Now, you've got to be consistent. What do you have up top right here? AB. So what's AB over here? 8. What's in the bottom right here? The number that corresponds to BC, correct? So BC here is x. So you must set it up like this. 4 over 7 equals 8 over x. Or I guess you could do this. You could also say 7 over 4 equals x over 8. You'll get the same answer either way, okay? Alright, let's go ahead and cross multiply. And let's see what we come up with, okay? 4 times x is 4x. 7 times 8 is 56. Divide both sides by 4, and x equals 14. So there we go. The distance or the length of BC is 14. Alright, number 32, same thing. So here we go. We have AB is 4 over 7. The number that corresponds to AB is up top, and the number that corresponds to BC is in the bottom. So AB over here is x. X goes up top with AB, and then BC 21 goes in the bottom. Let's cross multiply. So 7 times x is 7x. 4 times 21 is 84. Divide both sides by 7, and x equals 12. Okay, the answer would be 12. All right. Okay, moving on to numbers 33 and 34. Now, the ratio they're giving us is this: DE to EF. DE to EF is 2 to 3. Alright, now let me copy that real quick so I can use it for the next problem. We're going to use that ratio there for numbers 33 and 34. So here we go. I'm going to put 2 over 3, and this would be my DE up top. 2 corresponds to DE, and 3 corresponds to EF. Okay? Now, let's see, we're solving for x. Here's DE right here, 5. DE goes up top. EF is y plus 3. EF is in the bottom, so y plus 3. Okay, let's cross multiply. 3 times 5 is 15. 2 times y plus 3, well, 2 times y is 2y. 2 plus 3 is 6. Set them equal. Bring the 6 over, make it a negative 6. That gives you 9 equals 2y. Divide both sides by 2, and you will get 9 over 2, or 4.5, or 4.5. Any of those answers are acceptable, okay? Alright, number 34. Exact same type of problem again, so here we go. We're going to use this ratio here. 2 over 3. 2 is my DE. 3 is my EF. Equals, okay, now 2 corresponds to DE. Y minus 2 corresponds to DE, so y minus 2 corresponds to EF. 12 corresponds to EF. So 12 goes in the bottom. 2 times 12 is 24. 3 times y minus 2 is 3y minus 6. Bring the 6 over and make it a positive 6. So we're left with 30 equals 3y. Divide both sides by 30, or by 3, excuse me, and 10 equals y. Okay, so there we go. The answer would be 10. Okay, moving on to numbers 35 through 38. Now please watch these very carefully. These can be pretty confusing problems. Now, number 35, Gulliver was 6 feet tall. What was the ratio of his height to the average height of the, I have no idea, Lilliputian, the Lilliputians, okay. Anyways, well, now be very careful if you look in the directions above number 35. You will see the average height. The average height of the Lilliput people is 6 inches, okay? So the ratio of his height, that's 6 feet, to the average height of the Lily people, well, theirs is 6 inches. Now remember, we really don't want it. We're not going to have a ratio that's inches and feet, so we can convert inches over to feet, which would give me a fraction, because 6 inches is a half a feet. Or I can convert everything to inches. It's probably easier. And just so you know, students, you'll get the same answer. You can convert both of these to inches, or you can convert both of these to feet. You still get the same answer. 6 feet would be 72 inches. So I have 72 inches over 6 inches. Well, 6 goes into both of those numbers. So I end up with 12 over 1 or 12. But I prefer 12 over 1. So my ratio would be 12 over 1. Alright, moving on to number 36. Now, read this carefully. It can be confusing. After leaving Lilliput, Gulliver visits the island of Brobdingnag. The ratio of the average size of these natives to Gulliver's. Now listen, ready? Please watch this carefully. If you will simply, students, read this sentence, and as you go write things down, you'll be totally fine. Watch. The ratio, so we got a ratio, put a fraction bar, of the average heights of the natives. So that's going to be the average height of the natives. How can we put this? We'll put average height of the Brobdingnag. So there we go. So look what it says, guys. The ratio, so I put a fraction of the average height of the natives to the ratio of his height, which would be 6 feet tall. The average heights of these people, the ratio of the average height of these people to Gulliver's, now look what it says next, was proportional. Now proportion means you have to have an equal sign with another ratio over here. Remember we talked about that. So it was proportional to the what? Ratio. So put your fraction bar. The ratio of what? His height. Well, that's Gulliver's 6 feet. Proportional to the ratio of his height to an average Lilliputian's height, which of course is 6 inches. Now, we have to put everything in inches or everything in feet. It'd be easier if we did it in inches, okay? So, 6 feet would be 72 inches. 6 feet here would be 72 inches. And now it says this, what was the Brobdingnagians' average height? So we gotta find this right here. That's my unknown right there. We'll call this whole thing x, okay? So 6 times x is 6x. 72 times 72 is 5,184. Divide both sides by 6, and x equals 864 inches. 864 inches was the average height, okay? By the way, that's pretty big. That's about 72 feet high, okay? About 72 feet high. Okay, moving on to number 37. Which of the following is the best estimate for the neck circumference of an average Lilliputian? I'm going to be honest with you. I'm going to be so honest with you. I have no idea where they got this answer. I don't get it. Now, maybe somewhere earlier I should have read something about neck circumferences in relationship to people's height or something. So I'm not going to really worry a whole lot about this one. It says here, excuse me for yawning, the neck circumference over the height. I just don't know. Either way, we're going to move on. Number 38. What was the ratio of the average Brobdingnagian's height to the average Lilliputian's height? Well, listen, first of all, what was the ratio? So put a fraction. Now, what's the average Brobdingnagian's height? We already said it's what? 800 and what? 64 inches. Did we not find that right up here? Read this. What was the Brobdingnagian's average height? Well, it was this right here. And now it says, what's the ratio of the average Brobdingnagian's height to the average Lilliputian's height, which is 6 inches? Okay. Now, actually, this fraction might reduce. In fact, it does. 6 goes into both of these numbers. 6 goes into 6 once, and 6 goes into 864 once, 144 times. So the answer is 144 over 1 would be the ratio, okay? I guess you could put 144 if you wanted to. I like to leave it a fraction when it says, what is the ratio, okay? But either way, that is how you would do that, okay? Alright, moving on to number 39. Okay, 39 through 42, the directions say to. You are given an expression of the form of A to B to C that compares the lengths of the sides of the triangle. Find the length of each side. Now, please, students, watch carefully, okay? Watch how I do this. This is very, very simple. Please take good notes. I've got BC, AC, AB, right here. BC is 3, AC is 4, AB is 5. Now come down here. BC, we're kind of making a little table, okay? Just so you can see things a little easier. Alright, now BC down here is 6. AC right here is X. Okay? And then AB is X plus 2. Now, students, I'm going to start with a ratio that I know, 3 to 6, okay? And actually, to be honest with you, be careful how I do this here. Yeah, we're going to do it like this. So I've got a ratio of BC over AC, 3 over 4, equals 6 over X, okay? So I've got BC over AC. Now, Mr. Earhart, why did you pick those two? Well, I'm going to tell you why I picked those two. I picked those two because I knew here there were no unknowns, and here there's only one unknown. So I knew I could use 3/4 and 6 over X, and that way I have one unknown. Okay, 4 times 6 is 24. 3 times X is 3X. Set them equal, divide by 3, 8 equals X, okay? So for this X right here, I can go ahead and put 8. Now the directions say to find the length of each side. So if X is 8, then here for X I can put 8. X plus 2 is 10, and we're done. The lengths of the sides of this triangle here are 6, 8, and 10. 6, 8, and 10. Pretty simple. Number 40. Alright, students, here we go. DE, EF, DF. 4 to 5 to 6. Okay, DE over here is 12. EF is Y. DF is Y plus 3. Well, I'm going to do the same thing again, students. I'm going to take these two numbers here that don't have an unknown, and this one here has one unknown. So my ratio of 4 to 5 equals 12 over Y. Okay, let's cross multiply. 4 times y is 4y. 5 times 12 is 60. Divide both sides by 4, and y equals 15. Now, we're going to find all the lengths of the sides, so y equals 15. And then put a 15 here. 15 plus 3 is 18. So there we go. The three sides are 12, 15, and 18. 12, 15, and 18. Alright, number 41. Same thing again, so here we go. Let's go with GH, HI, and GI. 2, 2, 3. GH over here is B. HI is B. And GI is B plus 2. Okay, now it really doesn't matter which two you take. I'm just going to take these two here. To be honest with you, I don't want to mess with a binomial, a two-termer right here. So I'm going to go with the top two. So I have 2 over 2 equals B over B. Okay, well, let's cross multiply. 2 times B is 2B. And actually, to be honest with you, as soon as we do this, students, I'm really wasting my time. There's nothing to even do here. Look, guys, this is so obvious. If 2 over 2 equals B over B, then 2 has to be, B has to be what? 2. And B has to be what? 2, because 2 over 2 equals B over B, or 2 over 2. So B has to be 2. So if B has to be 2, one side would be, and hold on, is that correct? Maybe I'm making a mistake here. Let's see here. Hold on 1 second. Maybe I'm making a mistake here. Okay, students, I'm back. I apologize. I did make a little mistake here. Okay, watch carefully what I did wrong. It's totally fine. I mean, if you're given a situation like this, where you're told 2 over 2 equals B over B, then obviously, B would, I mean, you would think B has to be 2 over 2. But think about it, guys. That's not true. B doesn't have to be 2. It could be 3. Look, 2 over 2 is 1. So B could be 3 over 3, or 4 over 4, or 5 over 5. Think about it. 2 over 2 equals 5 over 5. That's true. 2 times 5 is 10. 2 times 5 is 10. Or 2 over 2 could equal 4 over 4, which is still true. Okay, because 2 over 2 is 1, and 4 over 4 is 1. So we really can't use that combo there, because the answer is infinite solutions. So I'm going to use these here and see if I can come up with a different answer besides infinite solutions. So 2 over 3 equals B over B plus 2. Let's cross multiply. 3 times B is 3B, and 2 times B plus 2 would be 2B plus 4. Bring the 2B over, make it a negative 2B. 3 minus 2 is just B equals 4. And there we go. So if B equals 4, then this length here is 4, this length here is 4, and this length here, B plus 2, or 4 plus 2, would be 6. So 4, 4, and 6. Alright, number 42. Alright, here we go, students. Let's be very careful here. I have JK, KL, and JL. Alright, and the ratio is 1, 1, 1. Okay, JK is W, KL is W, and JL is 2W minus 4. Now, once again, let's try this right here. Watch what happens. Remember, you get 1 over 1 equals W over W. Now, right away, you think W has to equal 1. That's not true. It could be 10 over 10, because 1 over 1 is 1, and 10 over 10 is 1. So the answer to this would be infinite solutions. There's tons. So using these top two ratios is really not going to help me. So I'm going to go with the bottom two. Alright, so let's see what happens. Maybe I can get an equation here that actually works out to a certain number, not infinite solutions. So 1 over 1 is 1, W over 2W minus 4. Okay, let's cross multiply. 1 times W is W. 1 times anything is just itself, so 1 times 2W minus 4 is 2W minus 4. Okay, now bring the 2W over, make it a negative 2W. 1 minus 2 is negative W equals negative 4. Change the signs of both sides, or divide both sides by a negative 1, and W equals 4. So here I'm going to get 4, here I'm going to get 4, and then 2 times 4 is 8. minus 4 is 4. So the three sides would be 4, 4, and 4. Alright, moving on to numbers 43 through 46. Find the ratio of kitchen responses to bedroom responses. Well, this is really easy. Kitchen, bedroom, 36 to 13. Piece of cake, 36 to 13. Number 44. Kitchen to living room. Kitchen to living room, 36 to 25. Alright, number 45. Living room to bedroom. So living room to bedroom, 25 to 13. Alright, here we go, number 46. Now on number 46, it says, explain why you do not need to know the number of people surveyed to find the ratios. There's more than one answer, more than one explanation. I'm going to say it this way. Any percentage is over 100. So 13% is 13 out of what? 100. 25% is 25 out of what? 100. 36% is 36 out of 100. And 26% is 26 over 100. Okay? So, to be honest with you, when I had percentages here, I was really dealing with parts of 100. In other words, I had, if you look at it like this, 13% spent 13 out of 100, and 25% spent 25 out of 100, and 36% meant 36 out of 100, and 26% meant 26 out of 100. So I really did not look at those as percentages. I looked at them as actual numbers, which is fine to do. And so that is why you did not need to know the number of people that were surveyed to deal with just ratios. Ratios are just the numbers that are related to whatever topic you're talking about here. Okay, so that is the reason why, and there are many other reasons you could use. All right, number 47. This is a funny problem. In a cookie recipe, the ratio of flour to sugar is 3 to 2. If the recipe is doubled, what is the ratio of flour to sugar? Guys, it's still 3 to 2. Think about it. If you double the ratio, then you're going to use 6 cups to 4, correct? Double this and double this. Well, then after you reduce it, because ratios are technically always supposed to be reduced, so what it says, if the recipe is doubled, the ratio of the flour to sugar will be what? Well, guys, yes, you double 3 over 2 to 6 over 4, but then reduce it, and that's your ratio. Your ratio is still the same. Guys, the ratio is just saying this. For every 3 cups of flour you put in the recipe, you'll put 2 cups of sugar in. So it doesn't matter if you double it, triple it, or quadruple it. The ratio stays the same. For every 3 cups of flour, you will use 2 cups of sugar. Okay, that does not change. And then lastly, number 48. Okay, the sum of 2 integers is 72. Okay, so we're going to call my 2 integers x plus y. The sum of 2 integers is 72. If the integers have a ratio of 3 to 5, what is the value of the greatest integer? Now the confusing part, students, this problem is this. What do you do with the ratio of 3 to 5? Well, guys, think about it. It's just saying, and by the way, it doesn't matter if you call 3x and 5y, or if you call 5x and 3y, so don't get hung up on that. It doesn't matter. You'll get the right answer, trust me, okay? But listen, if we're saying 3 to 5, that means every x gets 3. And every y here, every 5, every y is going to get a 5. 5 times y, I like this. Let's go over that again, okay? The ratio is 3 to 5, so 3 times x would equal 5 times y. Now, students, you should recognize this from Algebra 1 or Algebra 2. How many unknowns do you have? 2. How many unknowns do you have? 2. So we have if you have 2 unknowns, then you need to have 2 equations. And we have 2 equations. So we can use elimination, substitution. I'm going to use substitution. Watch what I'm going to do. I'm just going to simply bring this y over and make it a negative y. So now I'm left with x equals what? Come on, guys, we should know. 72 minus y. Bring the y over, make it does x equal? 72 minus y. So what can I put for x right here? 72 minus y, because x equals 72 minus y. So for x, I'm going to put 72 minus y equals 5y. Now let's solve for y. 3 times 72 would be 216. 3 times negative y is negative 3y equals 5y. Now bring your 3y over negative and make it positive. So 216 equals 8y. Bring your 3y over and make it a positive 3y. 5 plus 3 is 8. Now divide both sides by 8 and you will get 27. 27 equals y, okay? Now, let's come back over here, guys, okay? Remember my original equation over here was x plus y equals 72, okay? Now, if y is 27, what would x have to be? 45. How do I know that? Because 45 plus what? 27 equals 72. Just take 72 and subtract 27, and you'll get 45. So, if y is 27, the next has to be 45, because 45 plus 27 is 72. Now, what is the value of the greater integer? Well, what's greater, 45 or 27? 45. So the greater integer is 45. Okay,